We often think of rivers like the Nile as these ancient constants, but sometimes human projects just, well, completely reshape the landscape.
They really do. And today we're looking at a prime example, the Aswan High Dam in Egypt.
An absolutely enormous undertaking.
Huge. Built across the Nile down in Aswan between 1960 and 1970. And when it was finished, it was actually the tallest embankment dam, earth and rock dam in the world.
Taller than the Château's Dam in the U.S., which was the record holder then.
Exactly. Quite a feat of engineering for its time.
And it wasn't the first dam in that spot, was it? There was an older one nearby.
That's right. About 7 kilometers, maybe 4.5 miles downstream, you have the Aswan Low Dam. That one dates back to 1902.
Okay.
But it was already being used to its full capacity. The high dam was about thinking much, much bigger.
And this bigger thinking came after a major political shift, right? The 1952 revolution.
Precisely. The new government saw the high dam as absolutely key for Egypt's future. They had, well, several big objectives.
Like controlling the Nile's floods.
Yes, getting a reliable handle on the annual flooding was major. Plus, they needed to store a lot more water for irrigation, basically to farm more land more consistently.
And power, I assume.
And power. Hydroelectric power was seen as essential for driving Egypt's industrialization plans. So like the Low Dam, but on a vastly different scale, it was set to change, well, almost everything about Egypt's economy and even its culture.
It's hard to even picture how big this thing is. Can you give us some numbers?
Okay, let's try. The length across the top is 3,830 meters.
Wow, that's nearly 2.5 miles long.
Yeah. And at the bottom, the base is incredibly wide, 980 meters, almost a kilometer wide down there.
Goodness.
It tapers up, of course. At the crest, the top, it's still 40 meters wide, and the height reaches 111 meters. That's about 364 feet.
Just massive. What's it made of? You said earth and rock.
Mostly, yes. An embankment dam. The sheer volume of material is staggering. It took 43 million cubic meters of rock and earth.
43 million cubic meters. That's incredible. How does something like that handle the force of the Nile? The water flow must be immense.
It is. The design included a main spillway that can handle 11,000 cubic meters of water per second.
Can you put that in perspective?
Well, think about nearly 400,000 cubic feet of water pouring through every second. That's a huge volume.
Okay, yes, that helps.
And just in case there are emergency spillways too, they can take another 5,000 cubic meters per second. So it really gave them unprecedented control over the river.
And all that controlled water had to go somewhere. It created a lake, didn't it?
Oh yes, one of the world's largest man-made lakes, Lake Nasser.
Tell us about Lake Nasser. The scale must be unbelievable.
It really is. Its total capacity is about 132 cubic kilometers of water.
132 cubic kilometers. Hard to visualize.
It is. The surface area it covers is 5,250 square kilometers. That's bigger than some small countries or states like Rhode Island. It stretches about 550 kilometers long. That's over 340 miles. And at its widest point, it's 35 kilometers or about 22 miles across. And it gets deep, too, up to 130 meters in places. It literally redrew the map of the region.
So water control, massive reservoir. What about the third goal of the power generation?
Right, the power station. That was commissioned in phases between 1967 and 1971.
Oh.
It houses 12 turbines, Francis-type turbines specifically, each one rated at 175 megawatts.
So the total capacity is pretty significant, though.
Very. It adds up to 2,100 megawatts installed capacity.
And how much power did it actually produce?
Well, looking at figures from around 2004, the annual generation was just over 10,000 gigawatt hours.
That sounds like a lot.
It is. Think roughly enough to power maybe a couple of million typical homes for a year. It became a really vital source of electricity for Egypt's development.
So it's clear this was just a monumental project driven by this powerful vision for Egypt. The engineering alone is staggering.
Absolutely. It really shows what can be done when there's a determination to harness natural resources for national goals, for fundamental needs like water and power.
So this incredible dam, built for flood control, irrigation, power.
Yeah.
It definitely delivered big changes for Egypt.
Undeniably. You know, on those primary goals, it was largely successful. It brought a much higher degree of control over the Nile's unpredictable floods and droughts, things that had, for millennia, dictated life in Egypt.
Right.
And the stored water meant a huge increase in irrigated land, more crops more often. And as we said, the power was, well, instrumental for industry.
But with projects this massive, the benefits rarely tell the whole story, do they?
Yeah.
There must have been significant downsides, too. Social environmental impacts.
That's a really crucial part of the picture, yes. The economic benefits were there, but the social cost was high. Over 100,000 people had to move.
100,000.
Yes, mostly Nubian communities whose ancestral lands were flooded as Lake Nasser filled up. It was a huge displacement with really profound, long-lasting impacts on their culture and their lives.
And the flooding didn't just displace people, it also threatened archaeological sites, didn't it? Ancient history submerged.
It did, and that caused a global outcry, actually. It led to this amazing international rescue campaign coordinated by UNESCO.
Ah, that's where they moved the temples like Abu Simbel.
Exactly. Abu Simbel, the temples on Philae Island, they were painstakingly cut apart, moved block by block to higher ground, incredible engineering feats in themselves, but still many, many other sites were lost forever under the lake.
A real loss. And beyond the human and cultural cost, what about the environment itself? Changing the Nile's flow so drastically must have had consequences.
Oh, absolutely. The dam completely altered the river's natural rhythm. A big one was trapping the silt.
The fertile silt that used to fertilize the fields downstream during the floods.
Precisely. Without that natural fertilization, Egyptian agriculture became much more dependent on artificial fertilizers. There are also ongoing issues and studies about things like coastal erosion in the Nile Delta, changes in soil salinity downstream. The exact impact is complex and still debated, but the dam was certainly a major factor.
It sounds like the Aswan High Dam is a classic example of a complex legacy. Huge progress on one hand, but significant challenges and costs on the other.
That sums it up well. Evaluating it means weighing those economic gains against the very real social and environmental consequences. You'll find different perspectives on whether the trade-offs were ultimately worth it. It's still something people analyze and discuss, even all these decades later.
It really makes you think about the long view on these massive infrastructure projects. The dam certainly shows our power to reshape the world for our needs, but it also highlights just how important it is to try and understand the full range of consequences, intended and unintended. It makes you wonder about similar projects elsewhere, doesn't it? What other monumental efforts have sparked these kinds of debates about progress versus its true cost? Something to consider.